This is the second lesson on circles, and it does get quite a bit harder than the first lesson. So take your time with this video, work through it at your own pace. I'll try and go through it slowly and steadily so you've got a chance to write notes. So we're going to find the equations of tangents and also chords to circles and normals, which are actually, in the case of a circle, the radius or a radius. Looking at this graph to start with, we can see that this line intersects this circle, this red circle, the blue line intersects at these 2 points. This point being -2, -1, and this point here 0, 1. We can see there. When a line and a circle meet, as we know, when any line and curve or 2 lines meet, the points of intersection, the x and the y values are the same. In other words, the coordinates satisfy the equations of both. So if we substitute these coordinates from this point into the equation of the line, we can see that it works, that the right-hand side is equal to the left-hand side. And similarly, if we put the x and the y value from the coordinate pair into the equation of the circle, again, it works. We get the left-hand side equal to the right-hand side of the equation. So both equations satisfied by the point -2, -1. To find the points of intersection of a line and a circle, we need to solve the equations simultaneously. So very similar to what we did recently with lines and curves. So looking through this example here, we'll put x plus 1 in for y. This is what we're putting in. So we need to simplify it and then make it equal to 0 on the right hand side. So we've got this part here. You can see here that the x plus 1 minus 1 is going to just equal x squared, isn't it? The plus 1 and the minus 1 will cancel. So we can simplify it to this. If we then expand out this bracket, we get x squared plus 2x plus another 2x plus 4, which gives us x squared plus 4x plus 4, then plus x squared. And then if we subtract 4 from both sides, we get -4 on the left-hand side, and it leaves us with 0 on the right. Tidy this bit up. We get 2 lots of x squared plus 4x. Plus 4 and -4 cancel. Observing the discriminant, we can see in this form we've got our a value is 2 because it's ax squared plus bx, so our b value is 4, and we haven't got a c, have we? So c is 0. So here we've got b squared minus 4ac. So we get 16, which is positive, which tells us that the equation has 2 distinct real roots. So we take the x out. We can also take 2 out, can't we? Because 2 is a common factor of 2 and 4. So take 2x out, and that gives us solutions when x is 0 and when x is -2. If we now sub in these values into the linear equation, we can find our corresponding y values. When x is 0, y is 1. And when x is -2, y is minus 1. If the line does not cut the circle, there are no points of intersection. So if it's a quadratic, we get no solutions when the discriminant is negative. So if we consider this line and this circle here, same process as before. We sub in the x minus 1 for the y here. This time we get this. Tidy it up. We end up with this quadratic here. And the discriminant is minus 32. It's less than 0, which tells us that there's no points of intersection. So this line will miss the circle. It won't intersect or even touch the circle. So there is a third possibility with the discriminant. We've looked at what happens when it's greater than 0. We've looked at what happens when it's less than 0. If the discriminant is equal to 0, then the lines are tangent to the curve. It means it has equal or repeated roots. Again, like our quadratic curves and our straight lines we looked at previously. So to summarise then, these are the three different conditions. If there's 2 points of intersection with a line and a circle, like so, then the discriminant is greater than 0, it's positive. If the discriminant is less than 0, negative, the line will miss the circle. And if the discriminant equals 0, then the lines are tangent to the circle. Okay, have a quick go at this. See how you get on. I'll pop the answer up in a minute. Okay. So solution to the first one then, same as before. If we put our y value here, which is 2x in this instant, in for the y values here, simplify, look at the discriminant. We can see it's positive, so we'd expect 2 points of intersection. If we factorise and solve, we get 2x values. If we try these now back in the linear equation, we get our corresponding y values. So 0, 0 and 2, 4. Part B, same again, sub in the y value from the linear equation into the circle equation, tidy it up. It's a little bit more complex this time, isn't it? We're then looking to solve this. Let's observe the discriminant. We get 0, so that suggests a tangent. It suggests a repeated or equal root. We can factor the 5 out. That will help us. And we can see here that if x is 3, we have that solution. Put that into the linear equation, and the tangent is at the point 3, 3. If we look here, we can see that any tangent to the circle, if we can remember this circle property, is going to be perpendicular to the radius. So in other words, the radius is part of the normal to the tangent, isn't it? It's a line segment that is part of the line that's perpendicular to the tangent. So we can use this to find out equations of the radius. Or we can use the radius to give us the gradient of the tangent. I will always advise you to draw diagrams when solving circle problems. Draw it out and it tells you a lot of the information visually, makes it a lot easier to answer the questions. So we're trying to find the equation of the tangent at the point 5, 7 on a circle with centre 2, 3. So we can put that information in. 2, 3 is the centre. It's worth putting this roughly where it would be. Well, 5 and 7's bigger than 3, isn't it? So up there somewhere. So anywhere there. Give you a rough idea. So the tangent will look like that. And that instantly gives us quite a lot of information. We can see the gradient's negative, because as we move in a positive x direction, the line's going down, isn't it? The y value is getting smaller. So it's a straight line. We need the gradient. Because the tangent is perpendicular to the radius, if we work out the gradient of the radius between 2, 3 and 5, 7, we can then use the negative reciprocal of that, minus 1 over m if you like, to find the gradient of the tangent. So the gradient m1 is the difference in y over the difference in x, and we can then use, to find the m we need for our equation of the tangent, we can then use the fact that it's the negative reciprocal. It's minus 1 over the gradient of this normal, if you like, the radius. And then once we've got the m, we can sub in any values on the line, can't we? We've only got one. We've got this 5, 7, so we can use that value for x and that value for y to find what c is. Or we can use the equation y minus y1 equals mx minus x1 and use 5 for x1 and 7 for y1. So let's have a go at that. The gradient then of this line, the m1, is 4 over 3. That tells us that the gradient we want for the tangent is minus 3/4. So we put the minus 3/4 in here. The point on the tangent we've got is 5, 7. So we put those values in, find out c. We get this equation. We generally don't leave numbers in the denominator, do we? So we multiply through by 4 to get rid of those. And we end up with an equation that looks like that. Here you'll notice we've also taken the x over with the y. Okay, I'll draw this before I explain it. If we've got a perpendicular from the centre of the circle that goes through a chord, then if it's perpendicular, in other words if it makes a 90-degree angle, it will bisect the chord. So these two lengths are the same. So we're going to try and find, well, this is the midpoint of a chord, so we're going to find an equation of the chord. Well, to do that, if we draw first, as we've done before, write on the points, well, we know that that midpoint there is 4, 3. The other information we're going to have to get from here. So we need to complete the square to get the information from the circle. So we complete the square to find the centre. That will then enable us to find the gradient of the radius. Because the chord is perpendicular, we can use the negative reciprocal then for the gradient of the chord. And then we use our normal method like we used with the tangent. We substitute the values of that gradient in and the coordinates of the midpoint, 4, 3, to find our equation. So, complete the square. We end up with that equation, which tells us that the centre is at 3, 4. To find the gradient of the radius, we use the difference in y over the difference in x, using the two coordinates of the 2 points. And we get a gradient of -1. We're interested in finding the equation of the chord. So we need the gradient of the chord, which is the negative reciprocal of this gradient, which is of course 1, isn't it? So Rm is 1. Our x1 and y1 are 4 and 3. We can either use the equation y minus y1 equals mx minus x1, or find out c using y equals mx plus c. So the equation of the chord is y equals x minus 1. Okay, time for you to have a go. If you can do this, then you'll be ready for the lesson. Okay, I'll show you the answers. Like so. We get 8 for C. So the equation is y equals minus x plus 8.